There is a last object I want to introduce today, and that is the scale contour, the scale contour diagram. And this scale contour diagram, I find that I've seen clients use it a lot because this contour diagram can be used as an IOW, an integrated operating window. So in here, rather than studying a set of temperature and pressure, right, at different locations, what this contour diagram allows you to do is to study a whole range of temperature and a whole range of pressure. Okay, so what you can do is to put them to use the minimum pressure that you have during production and the maximum pressure, and the same for the temperature minimum and maximum temperature, and see across that temperature range and pressure range where you will have a solid precipitation, or where will you have scale risk. Okay, so to do this calculation is really simple. We can just bring the software back, and we are going to go to the Actions pane and look for the Add Scale Contour icon. Okay, double click on it, and in this case, we are going to name this Olympus Contour. Okay, so in this Olympus Contour diagram, you'll see here in the middle of the screen that we don't have, it's not different from this, the scaling scenario or the saturator tool. It's the same. We are going to bring the type of fluid that we want to study. So we are going to click on Type. And in here, let's select the whole fluid option. I want to bring all the contents of the Olympus reservoir that I created. So let's select Olympus reservoir. Okay. And again, you don't need to specify mass because the software already knows how much of the gas and brine is present in this Olympus reservoir. Okay. The next tab is the conditions tab. And this one is slightly different from what we have seen so far. In here, again, we are going to define the temperature range and the pressure range. For temperature range, we can define the start temperature as the low temperature that we have during production, that is at the separator, which is 60 degrees C. And the highest temperature that we have is the one that we have at reservoir conditions, is 125. Okay. You can define the number of steps or the increments. So if you want to study temperature every, let's say that we want to study the temperature every 5 degrees C. So that means that we will calculate 13 different points. Okay. For pressure, we'll do the same. So in here, by default, is the logarithmic scale. Make sure that you unclick this, because we don't want a logarithmic scale. I want a linear scale. So for pressure, we'll use the low pressure. Again, that is at separator conditions. That's 30. And for the highest pressure, we will have, how much was that? 275 bar. Okay. For the increments, I want to do every 20 increments. So again, 60 to 125, increments of 5. Pressure is 30 to 275, and increments of 20 bar. The last thing, and you'll see, the software is always giving you a warning. There are no solids selected. That means that we need to go to the solid tab, and then you will select the standard. This is always a standard procedure, right? We are going to always click the standard solids if we want to allow solids to precipitate out, and then we go ahead and calculate. You can click on the plot tab, and in here, the software will start calculating every single pair of temperature and pressure for the scaling risk. Okay, so the software, you'll see that the default plot here is pressure and temperature as the independent variables, and the results that we are showing here is the total solid concentration in milligrams per liter. Or you can see this as the total amount of solids that are going to precipitate. Okay, this value of total solid concentration is also known as the maximum mass, or excess solute, which is the amount of material that can form from a solution that is at equilibrium. So this is also is referred to as the excess solute. And of course, you'll see that I have put very coarse steps here because I wanted this calculation ends very quickly. But you'll see that in the presentation, you can refine the steps as much as you want. Of course, if the more refinement you get, the more computation time is going to take. But in here, so you'll see, let's just use the presentation while the calculation goes. In here, what this is telling you is that at high temperatures and let's start maybe with the high pressure. So maybe that at high pressures and low temperatures, so it will be up here. In the upper left corner, the amount of solids that is forming is very, very small. It's not zero, but it's a very small amount according to my range here. At high temperatures and low pressures, that will be this bottom right corner here. This is the highest risk of scale. And I think the software calculated around 360 milligrams per liter for this corner here. At high pressure and high temperature will be here. This will be representing the reservoir conditions. And notice that this is kind of actually it's a white color, meaning that there are no solids that are going to precipitate there. Okay, there is no scale forming there. Since we defined it that way, we said that this is only at saturated conditions. Okay, so what I have seen clients do with this plot is we already have the pairs for temperatures and pressures, and they just plug them in here. They just put, say, you have the separator, so they put here, so they know that they will have a minimum or some scale formation. But let's say you are at 115 and 50, 115 degrees C and 50 bar, so then you are in the maximum scale formation at this condition. So you always want probably to avoid this area here. Maybe you don't want to be in the red area or in the green area. You want to be above this line here, the blue line, to reduce the amount of the scale information. Okay. Any questions about this plot? Like, this is so coarse, it doesn't look as pretty, but it's almost done here, at least in my machine. You can always refine the plot. I just wanted you to know or to show you how the software calculates this specific plot, the contour plot. Okay, at this point I will stop here if there are some questions about this and what we have done so far. Let me see. Let's go ahead and save. It seems that there are no questions. Is it a chat or hands raising? No. No worries. I will let you go very soon. And here will be lunchtime. I don't know from where you are joining today. Probably I hear some people maybe in London, or I don't know from where else we are having people today. Okay.
London.
London?
Near London.
Oh, okay. So I guess right.
Yeah.
Okay. Also, it must be late.